Hey everyone, Dave here. This mini lecture's on reacting masses. It's a bit hard to give a bit of a preliminary explanation for this. It's best if I just get straight into it. I'm going to explain this by actually giving you an example. So here's an equation. We've got sodium plus oxygen reacting to form two lots of sodium oxide. Now, the first thing that I'd suggest you do whenever you look at a new equation is you make sure that it's balanced. So when I look at this, I can see I've got 4 sodiums on this side, I've got 4 there, I've got 2 oxygens and 2 oxygens, so that particular equation is balanced. So we're working with something that's sensible, in other words. So here's what the question is relating to this particular equation, and it's asking you if you've got 5 grams of sodium that's reacting, how much sodium oxide will you produce? Now, this is just one example, but you can see here that where we're going with this is with the information that you've thus accumulated, you should be able to work out how much of a yield or how much material you get when things start to react. I think I'll just get my pen here, go for the red one. So how on earth are we going to answer this question? Well, it actually takes a little bit of mucking around. There's nothing you can do about it. I guess the first thing that I need to point out to you is that this equation here is, when it's balanced, it's telling you the proportions with which things are reacting and then producing particular products. So I start with 4 sodiums, it reacts with 1 lot of oxygen, it forms 2 lots of sodium oxide. Another way of looking at this is for every mole of sodium I get half as much sodium oxide. As you can see here, the ratio is 2:1. There's 4 of these for every 2 of these, which is the same as 2 of these for every 1 of these. So I'll put it another way to you. If I've got 1 mole of this stuff reacting, I must end up with half a mole of this stuff. And you need to make sure that you understand what I'm saying about this, because if you don't understand that point, it's impossible for you to understand the rest of this lecture. So make sure you get clear in your mind why it is that if I've got 2 moles of this reacting, I would get if I've got 2 moles of this reacting, I would get half as much, that is 1 mole of this. You can see the proportions will always be that for any given number of moles of sodium, I'm going to get half the number of moles of sodium oxide. So the problem with trying to work out this particular question is we're not given the number of moles of sodium, we're actually given the number of grams of sodium. And if you look back up here, I've only ever been talking about moles. So therefore we've got to convert everything to moles. That's just a little summary of what I've been saying. So how do we do it? Well, hang on. Okay, how do we do it? So here's our 5 grams of sodium. We've got to work out how many moles of sodium we've got. Alright, so we start, here we've got our 5 grams of sodium. We know what the molar mass of sodium is. Where do you find that? Well, you look it up in your periodic table. You can look up the atomic mass of sodium, and of course if you express the atomic mass in grams per mole, that's then the molar mass. So excuse me, by using this formula here, that is the mass divided by the molar mass, you can work out the number of moles of sodium. Now notice, to be able to do this, answer this particular question, you've got to have made sure you've mastered the previous lecture material dealing with calculations of masses and moles, etc. Alright, now we're on a really good track because we can start to figure out how many moles of sodium oxide are being produced. Well, we already know what the molar proportions are here. For every one of these, I produce half as much sodium oxide. So if I start with 0.2 moles of sodium, I must have ended up with 0.1 moles of sodium oxide, half the amount, or half the number of moles I should say. So what we do is we just do a little calculation here where we've calculated precisely that. The number of moles of sodium oxide is 0.2 of a mole. We have to take half that amount. To work out the number of moles of sodium oxide, you write down the number of moles of sodium. It's 0.2 of a mole. We're actually going to end up with half that amount, so it's 0.2 of a mole divided by 2 equals 0.1 of a mole. In other words, the number of moles here of sodium oxide is 0.1 of a mole. Now we're going to take our 0.1 of a mole of sodium oxide and convert it back into grams, because if we look back over here at this question, that's precisely what it's asking. What mass of sodium oxide is produced? How do you do that? Well, you know the number of moles of sodium oxide. You can calculate its molar mass, and then you just do a similar calculation to up here, but in reverse. So we've got 0.1 moles of sodium oxide, and we multiply that by the molar mass. What's the molar mass going to be? It's going to be 2 times 22.9, because that's the molar mass of sodium, and I have 2 of them in this formula, plus 1 plus 16 grams per mole of oxygen, because I've only got 1 oxygen there. I don't have to multiply it by anything else. So when you calculate all that out, it comes out to be 7 grams. So that's your answer. If I start with 5 grams of sodium, I'm actually going to end up with 7 grams of sodium oxide. And there's a very good chance that you'll have at least 1 or 2 questions in the exam, either in the interim exam or in the final exam, asking you to do something like this. Okay, as before, I'll also point out to you that you can listen to me do this as much as you like. What's important is you get in there and you start doing problems and getting used to doing the calculations, etc. That's how you're going to succeed. Okay, see ya.